Okay, this is Mr. Benson, and I'm going to show you how to answer every problem on this practice quiz, and let's see how I do. Maybe I'll make some mistakes. But the first question right here is how many distinct committees of 8 people can be formatted from people that are drawn from a pool of 20 people? Well, the first thing you got to ask yourself is, does order matter when we're making this committee? Is there a committee chair and all this other stuff, things where order would matter? Well, there isn't. So really we're just choosing 8 people from 20 people. This is a combinations problem. So there's 2 ways to do this. You could just, make your buckets like this. We have 8 buckets because you're choosing 8 people. I have enough buckets. I hope I do. 1, 2, 3, 4, 5, 6, 7, 8. And in the first bucket, how many options do you have? Well, there are 20 people, so there's 20 options for the first bucket. And the next bucket, you have 1 less option, and so forth and so on. So you got this 17, 16, 15, 14, 13. And after this, what you have to do is say, okay, this is how many different permutations that you could choose, 8 from 20. But remember, we don't care about the arrangement of it, so you got to get rid of the duplication. And to get rid of the duplication, you got to divide this by how many buckets you have. You have 8 buckets, so you got to divide it by 8 factorial. Okay, don't forget about that factorial, or some of you call it the upside down I, or you might call it an exclamation point. But that's how you divide it. So you're going to have to put this in our calculator. Well, I'm going to show you how you can put this in your calculator. It's nice and easy way to put this into the calculator. Bring it up right here. First, you had how many people that you had to choose from. So 20 people, and you're choosing 8 from that 20. So you put in 20 first, just like I did. You go over the math, go over to PRB, and go down to this NCR right there, the number 3 down. Push enter, and now you're choosing 8 from that 20, so you push 8, put that in there, and there's your solution. So there are 125,000, what was it after that? 970 ways. 970 ways to choose 8 people from 20. Moving on. Okay, how many different arrangements, can be made using all of the letters in the word topic? No, just topic. Okay, so we want to arrange it. It's a permutation because it's at a range. So we know it's a permutation. How many ways can you arrange it? The first thing you want to ask yourself is, are there any duplicates that we have to divide out? Well, there's only 1 T, 1 O, 1 P, 1 I, and 1 C. So you just figure out how many letters there are. 1, 2, 3, 4, 5. There's 5 letters. So there are 5 factorial ways to arrange this, and if we remember, 5 factorial is really equal to 5 times 4 times 3 times 2 times 1, and this, if I remember correctly, is 120 ways. So we'll put that in there. 120 different ways to arrange the letters in the word topic. Let's move on down to the next problem. Okay, a state lottery consists of drawing 5 numbers from the first 40 positive integers. Find the number of arrangements is permutations right there, arrangements of digits in the state lottery. The order of the numbers are chosen matter. Okay, 5 numbers, the first 40 positive integers. Okay, so we're losing a number each time. So we're choosing 5 numbers, so we have 5 buckets. 1, 2, 3, 4, 5. How many options do we have for the first bucket? 40 options, and 39, and then 38, and 37, and 36. And because order matters, we're not going to divide by anything, so we just got to figure out what that is. Now there's 2 ways to do that. Remember, what we're doing is we're multiplying these 5 numbers. Okay? And this isn't too hard to multiply in your calculator, but I want to show you another way to do it using the calculator. What you can do is, you know there was 40 numbers to choose from, right? So put 40 in your calculator. Then you go to math. You go over to PRB, and this one's a permutation, so you do NPR. And how many things were you choosing? You're choosing 5 numbers, so you push enter on that, and so you get your answer. There's, what is that? Okay, 78,960,960. That's huge. That's a big number. 78,960,960. Hopefully I put that one in right. That's how many ways you can choose 5 numbers from 40, where order matters. Moving on to question number 4. My refrigerator has 48 soda cans in it. There are 28 Pepsi cans and 20 Coke cans. Find the probability that if I randomly take 15 cans, that the exactly 7 are Pepsi and 8 are Coke. Okay, this is a tricky problem. We can do this. Find the probability. Ooh, holy cow! And then we gotta put that into the permutation. Let's delete that. I need some room for this one. Okay, so first thing. We got 48 soda cans, there's 28 Pepsi and 20 Coke. We want to choose, we're choosing a subset of 15 cans, 7 are Pepsi, right? Of the 28 Pepsis. and 8 are Coke, that's what I would totally get. I don't know why we put Pepsi in with Coke. Doesn't make any sense. Okay, so first we want to figure out how many ways can we choose 7 Pepsis from 28 Pepsis and 8 Cokes from 20 multiplied together. Okay, that will give us the total number of ways we can choose 7 Pepsis and 8 Cokes from a subset of 15 cans. Then what we need to do is find how many different ways you can choose 15 cans from just 48 cans. That's going to be our denominator, and then that will be put the numerator over the denominator. We'll get our decimal, and we'll put it in as a percent, it looks like. So let's do this first one. We're trying to choose 7 or Pepsi from 28. So hey, let's just do this in our calculator. That would be nice. Okay, so it's a choosing problem. Order doesn't matter. So let's use parentheses right there. We have 28 Pepsi, so we'll put 28 in there. Then we're going to click on math. We're choosing how many? We're choosing 7 Pepsis from the 28. Is that correct? Yeah, 7. Okay, close that off. We're going to multiply that by choosing 8 Cokes from 20. So we had 20 Cokes to choose from. Math, go over NCR, and we're choosing 8. Okay, so this should tell us how many different ways we can choose 7 Pepsis and 8 Cokes from the 28 Pepsis and 20 Cokes. That's how many ways we can do this. We can push enter right now. So there's tons of ways right here. But now we have to divide it by how many ways we can choose 15 cans from the 48 cans. So that's another one too. So we're going to divide what we got before. We're going to do another choose problem. We have 48 cans, and then we are going to be choosing 15 from that 48. So NCR, put that in there. Choose 15 from that 48. 15, make sure we get that in there. Bam. So, oh, this is nice. So we got 0.136. We want to go to the nearest tenth. So 0.1364, 0.1364. But we got to change it to a percent, so we're moving over. So we got 13.64%. We got to focus on the nearest tenth because it says tenth there. This is a 4, so we drop this just as 13.6. That's what we put in there. And then it says to put that percentage in there, so I'm going to put it in there because that's what it says to do. So I do it. 6%. There we go. Got it. Okay, hopefully I didn't get that one wrong. Whew. Okay. Next, number 5, a spinner is evenly divided into 8 equal areas. Okay, so we got spinner, it's like a pizza, divided into 8 equal areas, numbered 1 through 8. What's the probability of spinning a number less than 6? Less than 6. So 1, 2, 3, 4, 5. That's less than 6. Right as a fraction. Well, that's just 5 out of 8, right? Because there's 8 spots and 5 are less than 6. 5 out of 8. Okay, that wasn't too bad. Moving on. Oh, I can check these? No, let's see if I got that one right. Yeah, I did get it right. Let's see if I get these right. That'd be embarrassing. No! Oh, ignore that. Come back to that one later. Back to that one later. See where I made a mistake on this one. There we go. Okay. 13, 5 out of 8. Oh, there we go. Okay, I'll come back to the other one later because I'm kind of embarrassed right now. Okay. Going on this one, how many different arrangements can be made using all the letters of the word excelente without the A at the end? It's just excellent. Okay, first step right now. If let's say every letter was different, how many ways can you arrange it? Well, you can arrange it the number of letters factorial. So let's just count that up. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial ways to arrange it. Now, sadly, it's not that easy because we have duplicates. And let's say, see this E right here? If I swap with that E, when you arrange something, does that look different? Does excellent look different than excellent? No, they're the same thing when you swap those E's. So we got to get rid of this repetition. So how many E's do we have? Well, we have 3 E's. E's equals 3 of them. That's what I meant by 3. So we're going to divide this by 3 factorial. Okay, to get rid of the repetition of the E's. Anything else in here that's oh, look at the L's. There's 2 L's. Those are tricky. So there's 2 of them. So since the L is equal to 2, we got to divide this by 2 factorial to get rid of the ways. How many ways you can arrange those L's? Anything else in there? I'm scanning. I don't see it. There we go. That's our answer right there. So what is this? We got 3 factorial times 2 factorial. Oh, I'll just put it in my calculator. Just put it in there. Okay, so we got 9 math factorial divided by, okay, this is the key thing. Make sure you don't forget the parenthesis on the bottom. 3 math factorial, and we all know 3 factorial 6. So I don't know why I'm doing all this extra work to put this in here. And we know 2 factorial is just 2, but I'm still going to put it in there just because I don't know. Oh, there we go. Enter. And we get 30,240. Okay. 30,240. Check that one. Yes. Moving on. Pretty good at this math stuff. Okay, survey of 50 people showed that 37 people favored a new policy and 13 opposed it. Find the probability in a random sampling of 12 respondents from the survey. Exactly 6 favor the new policy and 6 oppose it. So we've taken 12. Well, this is just like the Pepsi problem, but now instead of having Pepsi and Coke, we have people who are for something and against something. It's just the same thing. Same thing. Kind of a difficult problem, though. Okay? So, first we have to figure out how many ways you can choose 6 that favor it from the 37 that favor it, and 6 that oppose it from the 13 that oppose it. And we're going to take those two things, we're going to multiply them. That's the different ways you can choose 6 that favor and 6 that oppose it. Then we're going to divide that by the sample size, or sample size of choosing 12 people from 50. Okay? So let's get our calculator out. Remember, so let's just organize our thoughts. These people that favor it, 37. Okay, right? Circle that. And we have 37 people favor it. We are choosing 6 out of our group of 12. Okay, and there are 13 that oppose it. Let's choose that in green. That's got to be green, doesn't it? And from that, we're choosing 6 that oppose it. Okay, and altogether we chose 12 respondents out of the 50 altogether. There we go. So those are kind of the groupings we're going to do here. So we'll use our calculator like I did before. Use a parenthesis. Let's focus on the people that favor it. You're choosing 6 from 37, so you have 37. Choose. Let's see, R, enter 6. Close that off. We're going to multiply that by, there were 13 that oppose it. You're choosing 6 from that 13. Okay, and then we're choosing 6 from there. And we're going to divide that by how many people were there. There's 50 people in this group, and we're choosing 12 for this whole thing. That's the kind of sample size of this scenario. Choosing 12. There we go. And bingo! There we go. And we need to change that to a percent first. So I got 0.0328. And remember, change the percent. We move this sucker over twice. So I got 3.28. And it says go to the nearest tenth because it said that. I'm going to look at this hundredth. The hundredth says it's an 8 because it's 5 or more. We're going to take this 2. We're going to creep that sucker up to a 3. So we really got 3.3% right there. Pump that in there. I'm going to put the percent because they showed it in the example. That's why I put it in there. That's why they put an example. So you do what the example shows, kind of. And you put 3.3 and oh, green. I love it. I love that color. Green's a great color. It's a good color to have. Let's move on. Problem number 8. There are 5 finalists in the Miss Stillwater pageant. In how many ways may a judge choose a winner and a runner-up? Now, because there's a winner and a runner-up, order matters. You don't want to be a runner-up. You want to be the winner, right? Okay, so there are 5 finalists, and we are choosing a winner and a runner-up. Because order matters, this is a permutation. How many options do we have first? We have 5 options. How many options next? 4. 5 times 4, that's just 20. No calculator needed for that. Let's put that in there. Nice. Let's look for some green. I'm looking for some green here. That's what I'm talking about. Moving on. Okay. Suppose a sandwich shop offers its customers a combo special. Each combo special includes 1 sandwich, 1 side, and 1 drink. Okay, this sounds good. If there are 12 different types of sandwiches, 6 different types of sides, and 10 different types of drinks, then how many combination specials are possible? Well, this is just the multiplication principle right here, where you have 12 different things. This is like dressing yourself. You have 5 hats, you have 10 shirts, and 6 shoes. You just multiply those numbers to figure out how many outfits you can wear. So we just have 12 different types of sandwiches, 12 times 6 different sides, which is 6 times 10 of the other one, different drinks. That's a lot of drinks. That's good. And we just multiply it all together. So we got 120 from this and this. That's 120, right? And then we're going to multiply it by 6. 120 times 6. So 12 times 6. We're talking 720. 720. Hope I didn't do the math wrong in my head. But I'm in a rush, so I'm in a rush. Slow down. You should slow down when you're taking the quiz. Let's try it. Yes, got it. Okay. How many different ways can 10 people be seated around a circular table? Okay, circular. That's a circle, right? Well, that's not even close to being a circle. Here's a circle, and there's 10 people, 3, 4, 5, 6, 7, 8, 9, 10 in that circle. How many different ways can you 10 people be seated around it? Well, the answer to this is just one less than 10, so 9 factorial ways to do that. The reason it's one less is if you took this circle that I just wrote on this board and you rotate it. I wonder if I can rotate it. Nope. Does it let me? Does it let me rotate it? Nope, it doesn't. What if I do this? Nope. If you rotate it, there's 10 spots to rotate it, and all those spots, even though you're rotating it, those are, I mean, it's in the same arrangement, you're just rotating it around. People are sitting in the same arrangement. So to get rid of that, you divide it by the number of people in a circle. So really, this is 10 factorial divided by 10. But 10 factorial divided by 10, that's just 9 factorial. So we're going to just figure out what 9 factorial is, and then we're going to be happy with the outcome. So put 9 math perb 4 factorial, and then we got 362,880. 362,880. Check that sucker. Green. Nice. Okay, evaluate these. Some of you maybe haven't seen these before, but you kind of need a calculator to do this one. What this is saying is if you have 15 things and you're choosing 3, how many different ways can you do this? And if you have 7 things and you're choosing 4, how many different ways can you do this? This is just a calculator problem, really. We just want to bring out our calculator and plop those things in there. So we got 15. We're choosing 3. Oh, I should have put a 15 in there, shouldn't I? Second, insert 5. There we go. And then multiply that by 7, choosing 4. Push enter to that, and we got 15,925. Let's see how we do on that one. 15,925. Check it. Oh. This is awesome. This is going really well. Okay. Number 12. How many different ways can 12 different runners finish in first, second, and third place? Because this order matters, okay? First, second, and third. You don't want to be in second. You want to be in first. You don't want to be third. You for sure want to be in first, but it'll take second more than third. So, we got 1, 2, 3 spots for first place, second place, and third place. How many options do we have for the first spot? Well, we have 12 options. So, you gave somebody first place prize. How many options do you have for second place? 11. And now for third place, how many options do you have? 10. So we have 12 times 10 times 11. 12 times 10 times 11. 20, let's just do that one quick. I don't want to make a silly mistake. I think I know what it is. 12 times 10 times 11. I don't know why I did that in that order. Is 1320. Let's put that in. Yes. 1320. Got it. Okay, moving on. Evaluate this. Okay, calculator problem. We're just going to evaluate. Oh, that's a big picture. I don't know why it's taking up so much space. So let's evaluate that. We got 12 math factorial. And I know a lot of people are going to get this one wrong. I'll show you why. And then you're going to divide it by, and you can do 8 math factorial times 6 math factorial. Okay. Okay, I'm ready to push enter, right? What did I do wrong, though? Why can't I push enter right now? Why? Why can't I? Why can't I? Well, here's why. Because you did not put parentheses on the bottom. Because really what this is saying, do 12 factorial divided by 8 factorial, and then take that whole thing and multiply it by 6 factorial. But that's not what you want. You want to take the 12 factorial and divide it by both 8 factorial and 6 factorial. So you have to insert parentheses at the bottom, just like this. Check that out. Once you do that, you're set to go. What did I do wrong? Factorial 16.5. Is that really what it is? That's weird. I'm gonna double check this. I'm just gonna put like a multiplication thing right here in the middle, just to make sure there's not something weird going on there. Okay, 16.5. Usually you don't see that with counting things, but it can happen, I guess, when you just go with random things like that. So, answer 16.5. This better be right. I'm gonna be mad. Let's see. Yes. Gosh. Keep going. Okay. 14. Mario, Lupe, Neil, Jim, Sam, Homestar are in a math club. That's nice. We got 1, 2, 3, 4, 5, 6. Homestar. never heard Homestar before. The club advisor will assign students to a 2-person team at the next competition. Okay, that makes sense because it's competition too. How many different 2-person teams can be formed from this? Well, so is this a combination or permutation? Well, to me, I don't think there's any order in choosing these teams, right? You can choose Mario or Lupe or Mario. That's the same team. So this is a combination scenario to me. So how many people do we have to choose from? 1, 2, 3, 4, 5, 6. So we have 6 people to choose from. And how big is our team? 2. So 6 choose 2. You can put that in your calculator, or you could do something like this. This one's not too hard. You've got 6 options for the first one, 5 options for the next one, and this is just equal to 30. Now, I promise you, if you put this in your calculator, you will also get 30 for this. Okay, let's put that in there, 30. Click check, move on in. What did I do wrong? Oh, what did I forget? You know what I forgot? Oh, you know what I forgot? Remember, because it's a combination problem, we got 6 and 5. What do you have to do with that? You got to divide onto the repetition. Gosh. So how many ways can you arrange these 2 buckets right here and right here? Well, there's 2 factorial ways to arrange it. So this is really 30 divided by 2, and that's 15. I am sorry, everyone. Even the greatest, which I'm not, make mistakes. There we go. Okay, moving on down. Well, let's check it. Just so you believe me. That's right. Yeah. Okay, 7 factorial times 3 factorial. Again, this is just a quick calculator thing. Let's just put in 7 factorial. Actually, I'm going to check this thing so I don't have to go. I'll delete some of this stuff out of there. And then change that to a 7 times 3 factorial. What's 7 times 3? Yeah, there we go. Delete that. And we got 30, 24, 0. 30, 24, 0. There we go. Good. Moving on. Problem 16. How many different seating charts can be made if a classroom has 36 desks and there are 34 students in the class? Okay, so this is the... does the order matter for this one? This was a weird one. I'm kind of asking myself, does order matter? Does order matter on this one? It doesn't seem like they're in a row or anything like that. So I would say in this situation, order does not matter. Woo! Excuse me. So let's just go with this as a combination. And if it doesn't work, well then we'll choose another one. So you're choosing 34 desks from 37. How many different seating charts can be made? I got a trick for you. Ready for this trick? So some people might say, okay, this is what you got to do. You got 34 students in class, right? You're choosing 34 students from 36 desks. You're giving these desks to the students, right? So you have to have 34 buckets. I wonder if this would work. Okay. How many options do you have for the first student to choose from? You have 36 options. And then for the next one you have 35 options. This is going to take forever. 34. I don't know if I have a trick for this one. 33, 32, 31. How many boxes do I have? 1, 2, 3, 4, 5, 6, 7. Oh, this is going to take forever. Let's not do this. Let's just go to our trusty calculator. Let's just do it this way. You have 36 things. You're choosing 34 things from those 36. How many different ways can you choose 34 from this 36? Right? Yeah. So 36, math, go over there, choose 34. And we get 630. There we go. 630 ways. Gosh, what was I doing wrong? My bucket thing wasn't seeming to work. How was I doing that one wrong? Let me take a look at that. You have how many different seating charts can be made if you have 36 desks and there are 34 students in the class? Oh, but then remember, because the combination doesn't work. Oh yeah, check this out. So we have 36 times 35 times 34, 33. This goes all the way down to like 3, right? But then you also have to divide that by how many different ways you can arrange 34 things. Well, if you can arrange it 34 times 33 times 32 times 31. Notice as I go down, this 34 cancels that off as we go. So really you just have 36 times 35, and I bet 36 times 35 is the 630. Is that it? Let's try that out just to make sure. 36 times 35. Oh, but then you got to arrange it the 2 ways. You arrange it 2 ways, and then you get the, yeah, 630. There we go. Oh, let's check it. I didn't even check it. What? It's not 6:30? That one is 6:30. Mark for the submission. Let's go back to that one later. 6:30. I think that one's wrong. I think I'm right. I'll take a look at that one later, though. We'll come back to it. Okay, if no two letters are repeated and the letters do not have to form a word, how many different four-letter combinations can be made from the letters E, F, G? So no two letters, so we can't repeat them. The letters do not have to form a word. How many different four-letter combinations can be made from E, F, G? Oh, well, there's four letters. So you can range them 4 factorial ways. 4 factorial is just 24. Okay. Let's check that one out. 24. Moving on. A lunch menu consists of 4 different kinds of sandwiches, 3 different kinds of soup, and 3 different drinks. How many different ways are there to order a sandwich of both soup and drinks? Oh, well, this is just the multiplication principle. So 4 of these, 3 of these, and 3 of these. How many different ways can you range? So you just multiply 4 times 3 times 3. 4 times 3. 3 times 3 is 9 times 4. We got 18, 36. This is equal to 36. There we go. Man, I can't believe I still got 2 problems wrong. I wonder if that's really wrong. I think so. Pretty sure that one was right. I should ask somebody. Okay, box contains 2 green, 4 yellow, 6 purple balls. Find the probability of obtaining a green ball in a single random draw. Okay, so we got to first find the sample size. Sample size is how many things are in there. Well, we have 6 plus 4 plus 2. 6 plus 4 plus 2 is equal to 12. That's your sample size. But you want to get a green ball. How many ways can you choose a green ball from there? There's 2 ways because there's 2 green balls. I'm trying to highlight that too. So really you got 2 out of 12 ways to do this, which is the same thing. Simplified form. It says simplify it, so that's 1/6. And it says do as a fraction simplified form. So I'll put my 1/6 in there, and I will go on to the next problem. All said and done. Yes. Okay, 2 cards are drawn in succession without replacement. So you draw a card, you look at it, you keep it in your hand, you draw another card, okay? From a standard deck of 52 cards. How many sets of 2 cards are possible? Well, since there's 52 cards and you're drawing 2, you have 52 for the first option and 51 for the next option. You multiply those 2 things and you get your answer. So, let's do that. 52 times 51. Enter. 2652. 2652. Check that. What? 200. 2652. Am I going crazy? What did I do? Oh, did I forget? Oh, did I do that? It's a combination again because order doesn't matter. I'm sorry, everyone. So it's 2652. But then we also have to divide it by how many ways, right? We had these $2 right there. 52. 51. How many ways can you order them? 2 factorial. I am so sorry. So we got to take that 2652 divided by 2. So 2652, divide that by 2. Enter. 1326. Wow. Mistakes. See, even it happens to all of us. It helps everyone. We make mistakes. That's why you got to slow down on this. Don't like rush through it like I've been doing. So I got a few wrong. I still got to check this one out again. How many different seating charts can be made in a classroom that has 36 desks and there are 34 students? Okay, 34 students. So I got 36 times 35. Did I forget to do something? I don't know what I forgot to do. I got 36 options for the first, and then 35. 36, 35. I'm sure that's just it. 36 times 35? 36 times 35. 1260. There's 2 ways to arrange it. Divided by 2. Boom. 630. What is going on? Check that. Gosh. I'm talking B-roll. Figure this out. Okay, state lottery consists of drawing 5 numbers from the first 40 positive units. Find the number of arrangements of digits, right? Order matters. In the state lottery, the order of the numbers. Okay, so this was supposed to be just a simple 40 numbers permutate 5. And it would, oh, did I forget? 7, 9, 8, 9, 6, 0. Forgot the 7. See? Don't forget those things. What? Okay, looking at it again. Did I misread something? 7, 8, 9. 7, 8, 9. Oh, 7, 8, 9. Gosh. 7, 8, 9. Look very closely at this. 7, 8, 9, 6, 0. 9, 6, 0. Okay, I think I got it this time. Check it. Got it. Okay. Coming down, coming down, coming down. Looking. I got this one wrong still. I'm going to pause. I'm going to talk to somebody. Okay, I think I figured it out. So whoever wrote this problem right here, they viewed it as a permutation and not a combination, which I kind of disagree with. Like, I don't feel like there's an ordering of the desks in the room. You just choose a desk. It's just like they're not lined up or ordered anyway. So that's not totally clear to me, but okay. So because it's a permutation, you have 34 desks, or 36 desks. 34 students get to choose a desk. So you got 34 spots. Okay, right? I'm not going to write all these because it's going to take forever. You go 36, 35, 34, 33, 32, all the way down to when you get to the last spot. Okay, how do we put that in our calculator? We're going to use the permutation option. So we have 36 desks, math, and then go to permutation. Oh, no, that's not it. Math. Go to permutations, NPR, enter, and then you're going to give it up to 34 kids. And that, oh, God, look at that, 1.86 E41. That's this one right down here that I already have selected, and check that. There we go, 100%, minus all the errors I made. So did I miss any other ones here? I got them all. Just scanning quick. Any red? I don't like red. Well, that's it. That's how you solve all these problems. Just, take a look at this video. Make sure you understand how to do all these things. Make sure you don't make the same mistakes that Mr. Benson made, and we should be good to go. Thank you.